So hello student. So the next topic is KVL and KCL. Okay. So please concentrate the topic because this is the most important topic. So what is the full form of KVL and KCL? The KVL means Kirchhoff's voltage law and the KCL is Kirchhoff's current law. Okay. So at first I'm start your KVL. Okay. Suppose, so what is KVL state that in a closed circuit, what is the meaning of closed circuit? This is the meaning of closed circuit. Okay, in a closed circuit, all the voltage drop or supply voltage of each element, the algebraic sum is 0 across the each element equal to 0. So what is KVL? In a closed path across any resistance or any sources, the voltage drop or voltage supply, the algebraic sum equal to 0. Okay. So this is a supply voltage and here I am seeing one resistance, this also resistance. The voltage drop across these two resistance and this is the supply voltage. The whole voltage or algebraic sum equal to 0. Okay. So how to calculate? Suppose the value of this supply voltage is 10 volt and the value of this resistance 2 ohm, this is a 4 ohm. Okay. If I am find the value of current, I, then what? And I am applying KVL. Okay. Always KVL apply in a closed loop. This is a closed loop. At first, give a current direction. This is a current direction. This is a normal circuit, normal series circuit. Okay. Where the current enter into a resistance, this point is called positive and leaving point is called negative. Positive, negative. Okay. If this is a resistance and the current is entering this position, then the polarity of this resistance is, this is a positive and this is a negative. Okay, I think clear. Now I am applying KVL in a closed loop. KVL applied in a particular direction, clockwise or anti-clockwise. I am taking clockwise direction. So here we see that 3 elements in a closed loop, the 3 elements we have 1, 2 and 3. Okay. So first is a voltage source. This is a supply voltage taking 10. After that 2 ohm resistance. So across the 2 ohm resistance, the voltage drop is 2 into I. I am considering the current through the circuit is I. 2 into I, the voltage drop across this resistance. Now the voltage drop across this resistance 4 into I equal to 0. So both voltage are algebraic sum equal to 0. So algebraic sum means when I am taking this voltage source, then this is a minus. Why this is a minus? Taking this is a minus. Why? Because I am considering the first sign or first symbol. First sign means if I am walking through this position, the first sign is negative coming. That's why I am taking negative. After that, When I am coming this position, the first sign is positive. Now I am working through this road. The first sign is positive. Okay, equal to 0. So what happened? 2i plus 4i equal to 6i equal to 10. I equal to 10 by 6. Clear? So in a closed path, how to apply KVL? When I am applying KVL, I am always taking the first sign. Okay, taking the first sign. The first sign is negative, then positive, then positive. Okay. Now I am taking another example. Okay. If the circuit is looks like this, the previous current dividing rules problem, this type of circuit I am already solved through the current dividing rule. Okay, now I am solving same problem through a KVL or Kirchhoff's voltage law. Suppose this is a 24 volt supply and this is 2, 4, 2, 2, 4. Okay. So what happens? This is ohm. 2 ohm, 2 ohm, 4 ohm, 4 ohm. Now I am applying KVL here. At first I am giving the current direction because this is a basic principle. This is a basic principle to solve any circuit. At first you give the current direction. Okay. So you know this is a battery, positive terminal and negative. From the positive terminal the current will leave. Okay. This is a I. From this point the current will be divided into two parts. This is a I1 and we can say this is a I2 and also we can say I2 equal to I minus I1, right? Right or wrong? Right? Because I divided into two parts, I1 and I2. So also we can say this is a I1 and this is a I1 I minus I1. Okay. Okay. Now I am finished my current direction and assumption of current. After that I am applying KVL from this loop and this loop in any direction. If you take this is a clockwise and this is anti-clockwise, okay. If you take this is a anti-clockwise, this is also anti-clockwise, it's okay. If you take this is anti-clockwise but this is clockwise, it's okay. Everything. Okay, this is your choice. I am taking both in clockwise. This is a standard. I think this is a standard. Okay. So at first from here we goes. So first direction is minus 24. Then the current, where the current is entered into a resistance, this is a plus, this is a minus. So at first you write down applying KVL in loop 1. This is a loop 1. Okay. This is a loop 2. So what? Applying KVL in loop 1. Minus 24 plus 2 into I. 2 into I. At first I am taking the voltage from the source. After that I am taking this voltage across the drop of 2 ohm resistance, 2I plus 4 into I minus I1. I2 means I minus I1. So I am considering the drop across the 4 ohm resistance. Okay. Now this is equal to 0. So 2I plus 4I minus 4I1 equal to 24. What happened? 6I minus 4I1 equal to 24. The equation number 1. Now I am applying KVL in loop 2. So what is the question here? At first we write down or we see the question. At first write down the question. The question is find the current through this 4 ohm resistance. Find the current through this 4 ohm resistance, or this is called R4. So what is the question? Find the current through R4 resistance. Okay. Now if I am applying KVL at this loop, so now applying KVL in loop 2, what happens? Here the current is entered, is a plus, is a minus. If I am goes in clockwise direction, the first direction is minus 4 into I minus I1. Now 2 into I1 plus 4 into I1 equal to 0. Okay. So across the resistance, across this resistance I am taking the voltage. Across this resistance I am taking the voltage drop. Across this resistance I am taking the voltage drop. Okay. So algebraic sum of all voltage drop equal to 0. Now minus 4I plus 4 into I1, 2I1, 4 into I1 equal to 0. After that I am adding this 3. 4 to 4 means 10 I1 equal to 4I. So I1 equals to 4 by 10 into I. Okay. What is the question? Find the current through the R4 resistance. If I am finding the I1, then the question is solved. So now we need I. If I am put the value of I1 in equation 1, if I am put the value of I1 in equation 1, so write down, put the value of I1 in equation 1. Now I am getting 6I minus 4 into 4 by 10I equal to 24. 6I minus 16I by 10 equal to 24. Then minus 10I minus 10I equal to 10 into 24. 10 cancel. I equals to minus 24. I equals to minus 24. What happened? Okay. I equal to minus 24. Wait. When I'm check the. Okay, I'm silly mistake here. This is a 60. Okay, this is a 60. So 60 minus 16, 60 minus 16, 44 I equal to 24 into 10. Okay. Now I equal to 24 into 10 by 44 means 8, 11, 80 by 11. Okay, the value of I. So what is the value of I1? That means I1 equal to 4 by 10 into 80 by 11, 8, Okay, I think clear. I think clear all of you. Okay. Now this is a KVL. If you thought that KVL is more lengthy or KVL is more tough, not. If you able to apply the KVL in any circuit, then you solve any type of problem. Okay, this is the main part of circuit theory. This is the main part of circuit theory. Okay, now I am start your KCL. So what is KCL? Okay, KCL full form is Kirchhoff's current law. So what state that? So Kirchhoff's state that in an one point the incoming current equal to outgoing current. In a one point the summation of incoming current equal to summation of outgoing current. Okay, this is not an algebraic sum, this is a normal summation. Okay. This is a I1, I2, I3, I4, I5. So KCL state that in one point the whole incoming current summation, that means I1 plus I2 plus I3 equal to I4 plus I5. Okay. So this is the most important topic. Write down in your copy. Now I am solving one KCL problem. Okay. So wait 1 minute. So student, this is our next problem. Here the question is that, at first you write down the question. Okay, the question is that, what is the value of I1 and I2? What is the value of I1 and I2? So this type of problem is solved through KCL. Okay, here I am seen that one dependent voltage source. I think from the first video or first lecture, I think I am explaining all these type of sources. So this is a current source depend on current, that's why this is called current dependent current source. Okay, if I am looking this type of problem, always I am taking KCL to solve this type of problem. What type of problem is it, sir? Okay, seen that. Here, suppose this is a A, B point, this is a C and D point, This is a E and F point. This is a Z and H point. Okay, this is a Z and H point. Here I am seeing that across the AB point the voltage is, consider V voltage consider. Across the AB point voltage is V, and also CD point the voltage is also V. EF point the voltage is also V. GH point the voltage is also V. Why? Because in a parallel circuit the voltage remains same. If I am connected one resistance here, then only the voltage is not same through AB point and CD point, because the voltage drop will occur through this resistance. But our question is that this is a straight line. If no resistance are connected in this type of branch, then I am this type of problem solving through KCL. Okay, Kirchhoff's current law. So this is a AB terminal. The voltage of AB terminal is V. Equally, the voltage of CD terminal is V. Same voltage of EF terminal voltage V. GH V, because this is all our parallel connection. If I am this type of problem solving taking 2 point only, first point, this is a current source, second resistance, then this is a 4I2. This is a good approach to solve this type of problem. If you analyze at first the circuit diagram, then only the circuit is easier to solve. Okay, at first you thought how to simplify the circuit. Then you apply any rules or any method or any theorem, whatever. Okay, at first you draw the simple way. Okay, this is the I1, this is the I2. So if I am taking, this is the A point and B point, we know that the voltage across the AB point and CD, EF, GH all are same. That's why we can say this point AB and the voltage across these 2 points are V. Okay. Now I am seeing that this is a current source and this is also a current source. The direction is upward direction. Okay, and this current I1 and I2, this is a downward direction. That means these two current sources are incoming and I1 and I2 are outgoing from the point A. So now I am applying KCL at node A or point A. This is also a point or node, whatever you say. Okay. Now the incoming current means 5 plus 4I2 equal to outgoing current means I1 plus I2. Okay, so 4I2, that means 5 equal to I1 minus 3I2. This is equation number 1. Now to solve I1 and I2, we need one more equation. So from where we get the more equation? Here we seen the voltage across the 5 ohm resistance. V equal to 5 into I2. We can write V equal to 5 into I2, and also we can write V equals to 1 into I1, because the voltage between this resistance and voltage between this 1 ohm resistance are same. So we can also write 5I2 equals to, sorry, this is I1. 5I2 equals to I1. Okay. So if I put the value of I1 in equation 1, now write down, put the value of I1 in equation 1, then 5 equals to 5I2 minus 3I2, 5 equals to 2I2, that means I2 equal to 2.5. So what is the value of I1 from this equation? This is the equation number 2. From equation 2 we get I1 equals to 5 into 2.5, that means 12.5 ampere. Okay, I think clear. Okay. So thank you class. The next topic is nodal analysis. Okay.